Hello, everyone, and welcome to the Weekly Space Hangout for Friday, October 21st, 2016. I'm Fraser Cain, publisher of Universe Today. This week, we've got a bunch of cool stuff. We've got some folks live at the DEPS meeting in Pasadena. We've got some interesting stories about, dark matter galaxies, and a special guest. So let's get right into the show. Let's see. Here's the whole cast of characters. First, I'm going to say hello to Nicole. I've got great internet, Galucci. Nicole, welcome to the show.
Hi. My internet's not broken today.
No, your internet's fantastic.
Mostly not broken.
With the broken internet, we've got the team in the same room. We've got Sandy Springman, Morgan Renberg. Hey, guys.
Hi, how's it going? I've always wanted to be a telephone. High five. Right here.
So we've got their video at one part, but we've got their audio coming in through the telephone. And I apologize, their video, the audio quality is a little low, but that's only because their internet Wi-Fi is so terrible that this, I promise you, is 1,000 times better than having.
If you get me a Wi-Fi for the next meeting, we guarantee you it'll be much better. I'll send you my shipping address.
All right, I'll send you the Wi-Fi next time. Perfect. And we've got a special guest, Voula Saridakis. Welcome, Voula.
Thank you. Thanks for inviting me, and hello to all my followers out there.
Whoops. Let me see where I can find you again. I lost you. Where'd you go? You're pinned. That's the problem. Okay. There we go. I found you again. And that needs to get moved. Okay, great. So we are going to take a few minutes and we're going to talk with you about who you are, what you do, and then we'll move on to the actual show. So just want to remind everyone that this is a live interactive experience. We do this every noon on Fridays. So if you want to join us and watch the show live and chat with us and hang out, we'd love to have you. Just subscribe to this channel. Make sure you click on the notifications so you'll get notified when we go live and you can join us. All right, so Voula, welcome to the show. And just in case I'll be repeating myself here, who are you? And what do you do?
Okay, my name is Voula Saridakis, and I'm a historian of science. I specialize in the history of astronomy, and I graduated from Virginia Tech with a PhD in Science and Technology Studies, which is an interdisciplinary history, philosophy, and sociology of science degree. And soon after that, I moved to Chicago, and I started teaching. Back in 2002, I started teaching at Lake Forest College in their history department, teaching a wide variety of courses. And I did that for about 13 years. I'm actually taking a break right now from teaching so that I can get some writing done. And I'm working currently. I had completed an article and sent it in for review, and now I have to make all these revisions for a woman named Elizabetha Hevelius, who was married to a famous astronomer from Poland, Johannes Hevelius, and this is all late 17th century stuff. And I've got some ideas in my head about some more writing projects. And I'm interested in actually going into some freelancing in history of astronomy. So in astronomy and science-related magazines and online. So that's where we are right now. So I'm taking a break from the teaching and focusing more on the writing right now.
So, the history of astronomy is a pretty wide-ranging field. Do you have like a specialty in which aspects of the history of astronomy you're most interested in?
Yes, so I do 17th century astronomy. That's how I started off. My dissertation was on Johannes Hevelius in the late 17th century, and a little argument he got into with another individual by the name of Robert Hooke, who's a little more familiar to us in the history of science, who was over in London at the time, over the relative merits of naked eye versus telescopic sight. So that's what my dissertation was about. And so the focus has been primarily late 17th century history of astronomy and instrumentation, early 18th century. But I've also expanded into some other interests, primarily women in the history of astronomy. And so, for example, I wrote a couple of years ago an article on this woman named Margaret Bryan, who was headmistress in England in the late 18th, early 19th century. And she wrote 3 books that were books for her students, young girls who were her students. And she had a pretty solid science background as well. And I've looked at the books, and she appears in 2 of the 3 frontispieces, which they're really great to take a look at. That was the article I wrote about her, what she did and what she wrote about, and about her schools. And like I said, now I'm completing this article on Elizabetha Hevelius from the late 17th century. So that's sort of the emphasis of my work right now, but I'm kind of going more broadly, and we'll see what happens next as far as the writing is concerned. Yeah.
So what is sort of that period that you really study? What are some of the great discoveries, big advances that were made during that period?
Well, the late 17th century, this comes at the tail end of what is traditionally known as the scientific revolution. The revolution that begins with Copernicus and traditionally ends with Newton, so to speak. There's lots of things going on in there, and there's been a lot written about whether there even was a scientific revolution. How do we date the scientific revolution, which I'm not going to open Pandora's box and discuss that. But the late 17th century is the tail end of that. And so by the late 17th century, these instruments that they began using in the previous 150 or so years, like the telescope, the microscope, those had already become pretty well established. And the question at that point in the late 17th century becomes, what more can we do with these instruments? And this was what my dissertation was about, because the argument was for whether or not, I mean, we're all familiar with telescopic sights on, say, rifles, for instance, right? But the question was whether or not to put them on quadrants and sextants and other such scientific instruments. So it was a very transitional time in terms of how to use this new instrumentation, and what more could we do to augment our sense of sight so that we can be able to see the night sky better, make measurements between stars, say, better. And it was also the time in which you have the rise of scientific societies. So you have the establishment of the Royal Society in London, the Académie des Sciences in France, in Paris. And it was a time when, early on in the history of these societies, that they would write letters to each other, write letters for the Royal Society of London. They would write letters to the first secretary. I'm not sure if he's the first secretary. I believe he is, Henry Oldenburg. And he was really good at responding and receiving the letters. And he would tell foreigners like Hevelius, who I wrote about, he would tell outsiders who were on continental Europe, he would tell them about discoveries in London. And then they would find out about what the continental scientists were doing. So there was always this exchange, this correspondence. So you see the rise of these scientific networks as well in the late 17th century, and this very interesting process of, so this is what you're working on, and how interesting. And Henry Oldenburg would often, he would encourage sort of the butting of heads on all the latest discoveries and information and everything else that was going on. And so it was a very interesting time in science in the late 17th century when that was happening.
I mean, when I think about the 17th century, I mean, this is like before really our modern understanding of cosmology. Like now we know, like it's funny, I always talk about this, like I have this old astronomy book from like the turn of the 20th century, like, early 1900s, 1910 or something like that. And it says in there that Andromeda and things like that are nebulae, right? They don't know that these are necessarily galaxies that are completely outside of the Milky Way. They don't really understand the structure of the galaxy that we live in. We don't understand they just didn't understand all these things that, Hubble, in the middle, like 1920s, et cetera, started to really expand our comprehension of what the universe was. So what, take people back. What was sort of the worldview, or I guess the universe view of what these people had and the way they perceived our place in it back in that time?
Well, again, the late 17th century. So this is really before Newton's Principia takes a hold of the scientific community. It's more in the 18th century that you start to see Newtonianism and Cartesianism sort of butting heads and sort of challenging what the worldview was back then. But in the 17th century, like I said, it was such a transitional time, and people really trying to figure out what it was that they were seeing in the night sky. And because you have the telescope pops up circa 1609, 1610, and lenses back then, well, of course, were not that great. They were getting better and better over time, but initially they weren't that great. And so the issue then is to try to see and make sense of these objects in the night sky. And if you look at some of the works from the 17th century and the way that they drew various, like you said, nebulae, or the way that they observed Saturn, say, to try to figure out what are these things, they didn't think of rings. Most of them didn't even think that these were rings back then, to try to make sense of that. And so there's a lot of discussion about trying to make sense of all these objects in the night sky. But because it's sort of pre-Newtonian Principia time period, you really don't have, again, this idea of gravity and objects pulling on each other and all of that just yet. But it's very interesting. And there's all sorts of, Saturn is a really good example, I think, because again, there's so many works you can look at and opinions about what is going on, what is actually causing what we know as rings, what is causing that phenomena to happen? Are these little satellite bodies that are kind of moving around Saturn? Are these rings? Why does it seem that the size and the shape change? And there was a lot of debate about that in the 17th century.
And I mean, we've got the discovery of Uranus even, 1781. So this is still, before they even understood that there was more planets out there entirely.
Right. It's just really fascinating because when you look at how it evolves, especially with the rise of the telescope and instrumentation, and then you go from refractors to reflectors, and as the quality of the telescopes increase, just like as we see in the last 50 or 60 years, just as the quality increases, more and more of these really interesting discoveries are being made. And it's just amazing, I think, to read about them and to see what that process of discovery really was. So, to see them asking themselves in treatises or in letters, what is it that I'm observing? And frequently they'll talk about their instruments and what they're using, and to see that process happen from the 17th to, I think, the 18th century. It's a really, really interesting time to see those changes happening and those ideas in our universe shifting as a result of the rise of that new instrumentation and the increased quality of the instrumentation.
And this period really coincided with the advance of the scientific revolution itself, the methodologies. Got a question from Larry Beckham. Did Galileo really invent the scientific method? If so, what is his greatest achievement?
Galileo, I don't think invented the scientific method, I would say.
Yeah.
And let me put to rest, for once and for all, he did not invent the telescope, okay, one of the big myths in the history of science. So what he did manage to do, I think, is to take that telescope that had already been invented. He had heard about it, and he started to play with lenses and a tube and put everything together and was able to observe very far away and figured it out. But often I think what he gets credited as doing is he's the first, I think, to turn the telescope into a scientific instrument. So not just something where we could look and see ships in the distance and that sort of thing, but to turn it to the heavens and actually observe different things like Saturn, Jupiter, sunspots, the rough surface of the moon. Now, there were other individuals, I will add this, there are a couple of other individuals around that time period, maybe even right before Galileo, who observed sunspots, who did look at celestial phenomena with the telescope. But because Galileo published and he observed a number of different things in the night sky and wrote about all that, I think this is why he is so prominent, in addition to the fact, of course, that he gets in trouble with the Catholic Church. But so that's, I think, what his legacy is really to be able to challenge what people thought about where the role, what the place of the Earth was, the position of the Earth, by looking at these objects in the night sky and talking about them and starting this really interesting discourse, which unfortunately does get him into trouble in the end.
Yeah, I mean the research that I've done, he definitely did, when he was told to back down, he didn't back down. They give him plenty of opportunities to sort of be quiet and do as he was told, and he kind of didn't. And it apparently had quite a difficult personality. So I think I mean, he was definitely sort of the proto sort of antagonist in this. So I think it was great that he pushed the boundaries on that, and those are the stories that we have now, was that he was persecuted for following the science wherever it went.
Yeah, he was, and I've watched several different, over the years, programs and read a lot about the trial itself and the events leading up to the trial. And there's, I think, all sorts of interesting theories out there about the extent to which the Catholic Church kind of cornered him on this, as well as Galileo pushing back, like you said. But I mean, in the end, he accepted his fate and unfortunately was placed under house arrest for whatever he did. And this is how he ends his life. And I think that's part of the mystery and romanticization, if you will, of Galileo. Is that a word? Romanticization. So
we make up words all the time here.
Make up words all the time.
That's
okay.
Go ahead.
So I think that's part of the appeal of looking at Galileo in the history of science, is to see not just the fact that he used the telescope and said, hey, what's going on here in the night sky, but the fact that he got in trouble with the Catholic Church for it, and that connection with religion. Is often used as an example in the history of science for all sorts of different things.
So if you're a history fan and you're really interested in sort of following the trail of history sort of in the modern age, what are some of the resources that you really like out there? Apart from your Twitter feed, of course, which you've got lots of good stuff there, but where should people go looking?
Well, I have to say that as a result of the Twitter feed, I found some archives that I definitely need to go to and explore and see what's out there. So for my work, personally, I had to go to the Royal Society in London. They have a bunch of archives there. I had to do a bunch of research at Cambridge University Library, because they have a bunch of manuscripts there that I had to use, as well as Paris Observatory. But nowadays I find, well, it depends on your field, really. That's just me working on Hevelius in the late 17th century. So if you want to do Herschel in the 19th century, your archives are going to be elsewhere, obviously. But what I really appreciate nowadays is the fact that so many of these libraries and these archives are putting their collections online. So it's really easy to access. And that's what I've discovered through this Twitter account, really easy to access these manuscripts nowadays to see what's out there. And if you want to eventually go out there and actually have these manuscripts in front of you and study them, you could easily do that. But at least it gives you a good sense of what is available at such and such library or museum or whatever the case might be. So that's, I think, what I appreciate the most. Of course, it really helps me with my Twitter account that they have these collections online, and a lot of them have done a nice job of photographing their manuscripts and digitizing everything and explaining what they are. And kudos to all those libraries and institutions and observatories and museums that have done that. So it's become a lot easier to figure out where you need to go depending on what you want to study.
And there's nothing like seeing those original sources and just sort of seeing the original documents that these people produce.
Yes.
It's just amazing. So we got one last question for you from who's got to
I
be
have
your
one too.
biggest fan. Oh, you
you
got a
can-
question too. Okay, let me do one question from who's got to be your biggest fan. This is from Jungle George Miner, who might be in the same house as you right now. Wants to know what made you start your Twitter.
Oh, thank you, Jungle George Miner.
Jungle George Miner / Minecraft exclamation mark.
I wonder who that is.
Yeah.
So the reason I wanted to start the Twitter account was because I love the history of astronomy, not just the scientists, the astronomers and the instruments, but all sort of aspects of the history of astronomy. How does it encourage painters to paint the night sky? How does it encourage poets to write about the night sky? What do the archaeological artifacts tell us about what sort of Babylonians or Egyptians or the ancient Greeks thought about the night sky? I think the history of astronomy encompasses all of that. And I noticed on Twitter when I first signed up that there really wasn't anything like that. And I really just wanted to share the history of astronomy with people because I love it. I love reaching out to people about it. And I didn't think it was going to be popular or really go anywhere, it maybe get a couple of hundred followers. So I was actually very pleased to see that there were so many people and institutions out there that were interested in this material. And I try to make it interdisciplinary and multicultural because the history of astronomy, to me at least, is not just about astronomy in the West. Everyone in the world, all cultures have sort of looked at the night sky and wondered what it is that they're seeing up there. And artists have been influenced by what they're seeing out there. And that's what I wanted to bring to my audience and to my followers. Thank you for following.
Dr. Nicole Gallucci, you've got a question.
Yeah, I have a question on behalf of people who teach astronomy and who like to include the history of astronomy in their lessons. And in particular, so I'm wondering, in addition to your Twitter feed, if there are resources that teachers can look at to brush up on their history, make sure they get it accurate, but also I'm looking to expand it beyond what you typically see in every textbook, like the same three white guys, so that show that there's a more diverse background of people who've worked on astronomy throughout the centuries.
Well, first I say follow my Twitter account.
Yeah. Once I give her make Twitter work again. Yeah.
Yeah. No, so you're asking a very good question. And again, you don't want to be teaching the same three white guys, as you said, to, the students and all the famous hits in the history of astronomy, right? So one thing I would do is, like I said before, there's a lot of items and collections and syllabi that historians of astronomy who are teaching either history of science or the history of astronomy or the history of physics or the scientific revolution, because there's several different classes like that, to just do a search for syllabi to see what kind of resources they're using. I would definitely look for syllabi from the last 10 years, because if you go further back than that, you are going to run into more of that old-fashioned type of focus in the history of astronomy. So I would do a syllabi search for scientific revolution, history of science, history of astronomy, and I think that's a good place to start. And that'll give you a good idea of what current faculty are using for the history of astronomy in general. And you can go into so many different directions with that, and you can emphasize different cultures or different time periods. And there are some books out there as well, but I think that if you do the syllabi search, you'll find what they're using, and that'll be most helpful.
Fantastic. So, Dr. Saridakis, we got to wrap this up.
Okay.
But can you let people know where to find out more?
Okay, so if you want to find out more, definitely check out my Twitter account, which is at HistAstro, HIST. HistAstro. I have to say there is, for me at least, perhaps a slight nuanced difference between history of astronomy and astronomy history. History of astronomy is a field, And so that's why I started using the term history of astronomy. So it's at Hist Astro. And one of the things that I could also suggest that you do is if you're interested, say, in the moon and finding out more about the moon, just do a little search for moon at Hist Astro, and you'll easily find all these tweets I've done about the moon or any other subject that interests you. Is a good place to start if you're interested in a specific, say, planet or subject or time period or whatever the case might be.
Fantastic. Well, thank you very much for joining us on the Weekly Space Hangout. And
thank you so much.
And we will follow the Twitter feed from here on out. Thanks a lot.
Okay, thanks. And I'm actually going to stick around a little bit if that's okay.
Yeah, sure. You want to jump in and answer?
I want to hear about Planet 9.
Okay, well then jump in if you have a question. So
okay, great.
All right.
Planet 9 from outer space.
Aren't all planets in space?
Yeah, we'll get to you guys in a second, but I'm actually going to start before we're going to sort of tease everyone a little more because I'll have to change the audio level. So I think I'd like to get to Nicole's story first, and then then I will change the audio levels and we'll go from there. So Nicole, let's talk about the unexpected detection of dark matter galaxies.
Yeah, so actually my colleague down the hall sent me this in an email. It was I'll post the link in the YouTube chat, and probably I will get it over to the Slack chat as well, about a galaxy that's 99% invisible, which I had seen this headline come up a while ago. The story actually broke back in August about a galaxy that appears to be made of 99.99% dark matter. And the reason they came to this conclusion is they looked at it with telescopes. It doesn't seem to have a lot of luminous, stellar, normal, baryonic matter, however you want to put that, gas, anything like that. But it was very massive based on the velocities of the stars in the outer part of that galaxy and its halo. The galaxy is called Dragonfly 44, and why this interested me in particular was the picture that comes up at the top of the article, because there's this I don't know how to describe it, but there's this like bunch of little telescopes all together in this geometric shape. This started as a small side project that ended up detecting these galaxies. So in particular, and the name Dragonfly, I think, comes from the type of lens that they used. It was this really, really nice, photographic lens that they discovered that allows you to image really sharply, and what they've been able to do for astronomy is gather light from very diffuse, faint objects. So they've been surveying these super diffuse, barely there looking galaxies in fields that are already well studied, such as the Coma cluster of galaxies. So they've got a whole bunch of these together on these little telescopes that they've put together into this larger kind of array of, I don't know. My background, I would call it.
It's all right. I'm showing the picture, so people.
Oh, you are?
Yeah.
Okay.
So don't worry. I know you don't know that, but I'm actually showing the picture.
Awesome. So they've been using that to find these super faint galaxies. So like I said, so what I like about it is the fact that they've got this group of folks around this really cool instrument, because this is a way to do science, not necessarily using the big telescopes out there. Yes, they confirmed it with the Keck telescopes, but they're doing amazing science with these smaller instruments. And I also noticed one of the women in the photograph is wearing a Yuri's Night shirt, which makes me super happy. Yuri's Night being the big, space festival.
Bottom left-hand corner there, yeah.
Yeah, celebration of humanity in space. So that makes me super happy to see small instruments being used in really big ways. So check out that article. I'll post a little bit from the science article in the chat, and I'll also post the article about the instrumentation and the people behind it.
Now, I don't know if you've been sort of watching, but the opposite seems to be happening now as well, which is that people are starting to do surveys of galaxies and finding that you actually can explain their motion even without dark matter. So that, back in the day, the whole reason why dark matter was originally proposed was because galaxies were rotating too rapidly and that they would actually pull themselves apart without the dark matter halo surrounding them. But now, some new evidence is starting to show up that in fact a bunch of the galaxies don't need their dark matter and are actually rotating perfectly fine without it. So it's interesting that,
Yeah.
it's interesting. There's so many other ways now of detecting dark matter that people didn't even know of, looking for this, lensing to sort of find the concentrations of it. And now we're finding, as you say, entire galaxies where all the matter has been stripped out and you've just got dark matter left. But also maybe the opposite, which is entire galaxies that are perfectly happy without that dark matter halo. So
Yeah, the story of galaxy evolution and formation is still murky in a lot of places. And so could these be, big dark matter halos that didn't have a lot of baryonic matter and just a few? Are there dark matter halos out there that don't have any? It seems that there's a bit of a spectrum there.
Yeah, absolutely. It's an interesting time. And then, of course, the research that came up last week was that there's actually 10 times more galaxies in the universe than we thought, which was what Morgan was talking about last week. So now there's actually 2 trillion galaxies, but the same number of stars. So it's no different. So awesome, Nicole. Thank you so much. We're going to now attempt to switch to the folks at DPS. Morgan and Sandy. I may have to crank their audio, so you are going to have to, folks, you're going to have to talk me back up to an audio level that you're comfortable with. And just remember that other guests in the Hangout, you're going to come through very loudly if you attempt to talk. So just keep that in mind.
Okay, well, we're fine with that.
Awesome. All right, here we are. I'm going to boost your levels. Here we go.
Crank it. Are we going to 11, Fraser?
No. Well, yes, actually, if I look at the math, we are actually going about to 11. And folks who are watching, you're going to have to tell me if they're too loud for you. All right, so folks, Morgan, Sandy, where are you?
We are in beautiful Pasadena, California. It's a gorgeous day out there. It's clear. It's about 90 degrees, and it's a wonderful day to do science. And so we're here for the annual American Astronomical Society's Division for Planetary Science meeting, which this year happens to be in Pasadena. Last year we were in Maryland, and the year before that, where were we? We were in Tucson. It was great.
And so for people who don't know, what is sort of the purpose of this meeting?
This meeting is actually a joint meeting between the American Division for Planetary Science and the European Planetary Science Conference. So it's a joint meeting, and so there's about, 1,400 astronomers, planetary astronomers, and a couple of planetary geologists running around, and the point of this meeting is for everyone to share their science, get feedback, meet with colleagues. I'm actually have to run as soon as we're done here to go meet one of our collaborators who's building us an ultraviolet detector.
Also, lots of beer is drunk.
If you're Morgan, there has been beer and wine and sometimes.
I'm not interested in the alcohol that you guys have consumed. I only want to know about the science that you've consumed.
Morgan, sorry, go ahead.
So first, I think the thing that we talked about last week, we were all super excited, was how we were going to be seeing the arrival of the ExoMars mission at Mars. This is super exciting. 2 parts to it, the orbiter and the lander. How did it all go?
Yeah, it's funny. 2 years ago at this very conference, I sat here next to Sandy and talked about ESA's last mission, the Rosetta mission, which was dropping the Philae lander on the surface of Comet 67P. We talked about, how it really didn't go exactly as they intended. And I think that's a pretty fair description of what's happened in the last 48 to 72 hours. If you recall from last week, this ExoMars mission is made up of 2 parts. It has an orbiter called the Trace Gas Orbiter that's going to circle Mars and study the distribution of methane and other gases in the Martian atmosphere. And then there's a second part, the experimental Schiaparelli lander, that's going to touch down on the surface and measure dust quantities as it passes through the Martian atmosphere. And the good news is that the Trace Gas Orbiter performed a flawless Mars orbital insertion and is now the 6th spacecraft currently orbiting the red planet. And that's a shocking number of satellites for another planet. The bad news is that Schiaparelli didn't go quite so as planned. And unlike with Rosetta and Philae 2 years ago, there's going to be no recovering from this. The way this was supposed to work was that Schiaparelli would hit the Mars atmosphere, use a heat shield to slow itself down, then pop off the back of that heat shield and eject a parachute. The parachute would continue to slow it down in Mars's very thin atmosphere till it reached the speed at which the rocket engines could fire and propulsively touch the spacecraft down to the surface. And all of those pieces started, but none of them really went as expected. The heat shield, back of the heat shield popped off, but the parachute extended far sooner than it was supposed to. And when it extends too quickly, that means it's blowing out into air that's moving far too fast for it to effectively slow down. It's going to give a big jolt and jar the spacecraft, and it's probably not going to optimally slow down Schiaparelli. And then at the appropriate time, the rocket engines began firing. But instead of firing for the 30 to 40 seconds they were intended to fire, they only fired for 3 to 4 seconds. And then they shut off, and the parachute had collapsed by this point. And so from 2 to 4 kilometers above the surface of Mars, they went into free fall. And this is obviously not optimal. And after 2 to 4 kilometers of falling, they cratered into the surface of Mars. And we know this because just this morning, NASA and ESA released images taken by the Mars Reconnaissance Orbiter's wide-angle camera that showed a before and after of the Schiaparelli landing area. And you can see a black crater, and then several hundred meters away, you can see the white parachute that would have slowed it down.
That would have slowed it down.
This is the second major setback for the European Space Agency trying to land on the surface of Mars. 13 years ago now, they tried to land the Beagle 2 station on the surface of Mars, and it touched down seemingly successful, but it never called home. And it wasn't until about last year that they found it once more with the Mars Reconnaissance Orbiter and realized that after everything had basically gone right, it had never opened its solar panels. And it didn't have any energy. It couldn't operate its radio to call home. And this just reinforces how challenging it is to land on the surface of Mars. We've been trying to do this now for decades, and the United States remains the only country in the world that has successfully landed and operated a spacecraft on the surface of Mars. And we'd like that not to be the case, because the Europeans are hoping to land a rover in 2020 to complement the NASA rovers. But that rover is supposed to use the same landing technology that was being demonstrated here, and they haven't actually secured all the funding for that rover yet. And so saying, we'd like to build this rover with the same landing technology that just crashed, will you give us extra money to do it, is going to be a tough sell in Europe these days. And so this could be a major setback for the ExoMars 2020 rover, and just farther slow down our exploration of the red planet.
Yeah, it's problematic when you put a new crater on Mars unintentionally.
Yeah, as Morgan said, this is obviously not optimal.
No one did a good job exploring Mars until the last 20.
That's really been since the 2000s.
Early 2000s. And the only country that has successfully put an operational rover on the surface of Mars is the United States. So rah, American exceptionalism, except not really, because the more countries you have successfully exploring space, the better it is for everyone.
I feel really bad for the Russians. I mean, they have been hit hard by the Mars curse.
Yeah, but they went to Venus, and they're the only people who have landed on Venus. So, Venus is a lot harder than Mars, because Venus is awful.
Yeah.
Venus is toxic, and Venus has high pressure, and Venus is hot, and Venus is at least several circles of hell all rolled into one.
That's true. Okay, well, so let's. So what do we lose with the loss of this lander?
So we only lose a little bit. It's important to emphasize that for this mission, the ExoMars 2016 mission, the trace gas orbiter is the vast amount of the intended science. Schiaparelli was only intended to survive on the surface from somewhere between 2 and 8 days, depending on the temperature that the batteries were operating in. And it was going to make measurements that we've never made before about the dust and electric field environment on the surface of Mars. But again, it was only going to do that for less than a week. And so it's not like we've lost a major asset that we expected to operate for years on the surface of Mars. That is the case with the trace gas orbiter in orbit, and we expect that very soon it will begin relaying back very useful scientific data And so there's still every opportunity for this mission to succeed in nearly all of its objectives. And this failure is more, as I said, troublesome looking forward to the future of European exploration of Mars.
Well, this sucks.
I concur.
So let's maybe move on then to another story. As you said, there was a bunch of stuff happening at the meeting. A lot of stuff from Pluto. So do you want to maybe?
There's amazing things going on with Pluto. They found ammonia and water ice on some of Pluto's tiny moons, which are only a couple tens of kilometers across. They're not very large, and so we don't think that they have the mass and therefore the gravity to retain these volatile species that are very lightweight and can escape quite easily. So finding these unexpected materials, methane and water, on small moons is kind of quite a surprise. And so people will be arguing for many future meetings as to how they got there. Did something hit Pluto and inject this material onto the surface of these moons? Is this stuff temporary? How long has it been there? Morgan, you have anything to?
Oh, one of the things we talked about, I think, from this meeting last year is how the evidence suggests that the Pluto system is old, billions of years old. That's true for Pluto, it's true for Charon, it's true for the ensemble of small moons that are orbiting the pair. And very, very old moons is not very compatible with the notion of having something on your surface that shouldn't remain there. That usually suggests to us that this must have arrived or been deposited relatively recently and now has been disappearing as the adverse conditions strip it away. But if this moon's been there for billions of years, that means that somehow, relatively recently, this methane and water ice must have been deposited onto ammonia and water ice, must have been deposited onto the surface of the moon. And that's something that will be a puzzle for a while.
Okay, so we've got a few other things as well. Let's talk about, we know where Rosetta's comet came from?
This one's Morgan.
Yeah, so this meeting marked the beginning of the ExoMars mission, but it marked the end of the Rosetta mission, a mission that's now been studying Comet 67P Churyumov-Gerasimenko for well over a year. And the project scientist from ESA, Matt Taylor, came and gave sort of a final roundup of comet science during this meeting. And maybe two things from this overview sort of really grabbed the room. And the first one was the fact that they had finally found the location of Philae on the surface, and he shared for the first time some extremely high-resolution images of the rover, or of the lander, on the surface. And you could see it sort of laying on its side with its legs up in the air. And this elicited gasps in this packed auditorium from the scientists there observing it. And then secondly, he also shared the final line from the mission log transmitted by Rosetta as it impacted the surface of the comet. And so every few seconds, the spacecraft would be sending back status updates, basically, as to how its systems, et cetera, are operating during the course of a mission. And the last one was transmitted about a millisecond before the spacecraft crashed into the comet. And it read simply, warning, large object in field of view. And that really sort of got to people at the end of the mission, because ESA has done such a good job of anthropomorphizing both Philae and Rosetta. But he also did share some interesting insights as to the science on Rosetta. And one of the curious things that they noticed was that the density of Rosetta is actually, the density of 67P is actually lower inside the comet and higher near the outside of the comet. And this is something you could only figure out if you were flying very close to the comet like Rosetta does, over and over and over again. And you watched how the gravity from the comet would slowly alter the trajectory of your spacecraft. If you do this enough times, you can build up a map of the inside of the comet, and you can sort of work out what the density must be in different places to speed up and slow down the rover or the orbiter at different times. And so the fact that it's undense in the middle and dense on the outside, it sort of runs opposite to the way things like planets work. Now, the Earth is very dense at the core and relatively fluffy on the outside. And this ties into sort of the origin idea that they have about how this duck-like comet formed. We've believed for a while now that probably it was a collision between two objects that formed earlier on in the history of the solar system and then combined to form 67P. But the fact that it's very light on the inside and dense on the outside suggests that this origin impact must have occurred very slowly. Because you can imagine if you smack two things together, you're going to kind of shock them and crunch them down. It's like, imagine smashing two marshmallows together. Those marshmallows are going to get denser. But if you just slowly ooze marshmallows together, then you can maintain that light fluffiness on the inside.
I lost you there. Okay. So, do we think that we'll ever get...
Our internet has gone unstable.
Yeah, I can tell. I can see we're losing you. Your phone is still good, so you guys are a little... we lost your internet, but we still have you by audio, right?
Yep, yes. We got you.
Okay, there you are. Okay, great. Yeah. So I was just going to say, the next step, I mean, it's, we got our last round of images from their NavCam. That was just released in the last couple of days. So we're done with all the NavCam. There's still some of the images that are going to come out of their other better instruments, which we never get to see. But I mean, is that it? Are we done now with this comet now that we know its location? Any plans maybe to send a rover again in the future?
There's actually talk about maybe there are mission concepts, nothing set in stone, and nothing is certainly funded to send comet sample return to Churyumov-Gerasimenko since it's been so well characterized. There are a couple other comets that are candidates, but that is sort of out of scope. Fraser, I got a jet in 5 minutes, so I want to talk about Planet 9 from outer space. As Nicole did point out, those planets are from outer space, but
but this one's really from outer space. It's way out there.
So one of the cool results that a grad student actually presented at this meeting is that we can connect Planet 9, this possible Planet 9, quite possibly to the sun. Now, how the heck does that work out? So the sun has what we call an obliquity. So as the sun spins, it's actually pointed in space in a slightly different direction than the equatorial plane of all the planets. So you have the planets all on a plane here, but the sun's kind of tilted relative to that plane. There you go, Morgan. Thank you for being a good tilted sun. So that might be a leftover from how the sun formed, that you had this giant disk of gas and dust swirling and eventually condensed in the center, and the sun formed sort of tilted. But another explanation could be that Planet 9, way out there, is providing a torque on the sun, and that would actually cause the sun to tilt relative to all the planets in the solar system. So rather than the sun being straight up and down, it's tilted. So this means that if we do detect Planet 9 and we finally find its orbit and its mass, we could actually use that to figure out if the tilt of the sun is primordial, if the sun formed that way, or if it came from torques from Planet 9. So that's kind of cool, and that's going to be a really fun result to ultimately be able to verify if and when they finally do nab this thing. Also, there was some drama with someone who will remain unnamed getting upset at people who we shouldn't have gotten upset at about using the term Planet 9. I'll give you 3 guesses.
My eyes
anyway,
rolling into the back of my head right now.
No, I'm not gonna go into it.
Don't go there.
But
it's still cool that you can do sort of peripheral science from this hypothetical planet that hasn't even been detected yet, that it could possibly be affecting the orbits of these Kuiper Belt objects, and not only the Kuiper Belt objects, but it also could be affecting the tilt of our sun.
And so I saw really there was a bunch of research that came out of the conference. Not just this, but other people providing more evidence, helping to kind of narrow down the search parameters. Like Planet 9, you can't hide much longer. So we've got
as new telescopes come online that are more sensitive out in the infrared, hopefully maybe James Webb Space Telescope would be able to detect it. Maybe one of these LUVOIR concepts that was anywhere between an 8-meter to a 16-meter mirror in space assembled by astronauts. Maybe that would find it.
Well, I know you've got to
Yeah.
run. Who wants to talk about Juno?
Oh, Morgan knows all about Juno.
Yeah, so we've been talking about Juno now for some time. It arrived on July 5th to enter Jupiter orbit to study the magnetic fields of Jupiter, in addition to the clouds and atmosphere of Jupiter. And because Jupiter has this really powerful radiation field surrounding its equator, Juno is in a polar orbit. It goes up and down from the north to the south pole, dipping in just long enough to make studies, and then spending most of its time very far away, safely in a long period orbit. And when it entered orbit around Jupiter, its orbit was 53 days. So that's quite a long time. So it means it's getting very close to Jupiter for an hour or two, and then spending the next month and a half very, very far away. And the plan was that they were going to do 2 orbits at this 53-day period before ratcheting that down to a 14-day orbit. And that's good because in a 14-day orbit, you still only get a couple of hours in this close-in zone around Jupiter, but you don't have to wait a month and a half. You only have to wait 2 weeks. And in fact, the project scientists for Juno joked at this meeting that their plan was to make every other Wednesday Science Wednesday. Unfortunately, when they went to execute the maneuver to reduce their orbit, that involves firing a rocket to slow down the spacecraft and let it fall in closer to Jupiter, they discovered that one of the valves that was supposed to pressurize the tank, the fuel tanks, was stuck.
Oops.
And this is not a great thing, because it means you can't build up pressure for your fuel. You're not going to be able to adequately use your thrusters. And so they canceled that planned maneuver and decided to just turn this pass of Jupiter into a science orbit. Unfortunately, a couple of hours prior to its arrival in its science position around Jupiter, Juno entered safe mode. And this is when the flight computer basically detects that something is wrong and turns off everything that's not essential, points itself towards Earth, and just yells, "Help!" And unfortunately, and that's not terrible, because all spacecraft go into safe mode from time to time. Some do it more frequently than others, and that usually just means the engineers need to tweak something and do it again. Unfortunately, because of the timing of this particular safe, they missed this science orbit. And so now they have 53 days to wait before they can either try to fire the rockets again to change the orbit, or do another flyby of Jupiter to collect more science data. And that's obviously less desirable than what they were looking for.
But it's still alive. It's still fine, right? As compared to other landers that we
went
need to
out
be
of
aware
their
of.
way during the presentation to reinforce the fact that they can do all the science they want to do from the orbit they're in now. Because the amount of time they spend in this close to Jupiter period is actually the same, whether or not they're in the 14-day or the 53-day orbit. It's just a question of how rapidly they'll be able to collect the data. Originally, Juno was only supposed to be about a year-long mission. As they did every 2 weeks, they made a pass of Jupiter and made a new observation. And then if they were going to do it instead of 14 days, every 53 days, they'd have to extend that mission to be longer. And that would come at additional expense to NASA, but it would be a small expense in comparison to scrapping the mission and having to move on to something else.
Well, so how did it go? Did you guys have a fun time at the conference? Should I have been there? I almost came to this one.
It's a good meeting. I really like this meeting. Everyone is very friendly. It's good to see colleagues. We had a radar lunch yesterday. We took a lot of people who've worked at Arecibo, who've been part of Team Radar, and we went out and got tea. And we introduced someone who had never had a scone before to scones and cream and jam. So that was quite an experience. So it's really good to see people and talk about collaborations and help people find jobs and introduce people, since I'm a raging extrovert. I'm good at that. So and just sort of get a sense of sort of the broader topics in the field and what sort of to expect in the coming years from various missions and various other projects, and see people you don't see very often.
This meeting is often referred to as the family reunion for planetary science. And just like all family reunions, it's exhausting. And after a week, you want to go home and sit quietly for a while.
Yeah.
Even I need to hide after DPS.
But it's a tremendous amount of fun.
Oh, great.
Has there been any interesting science tidbits that aren't making the rounds in the media that you think were like, oh my God, this is so cool?
That's the answer is yes.
Uh-huh.
The second answer is, can we come up with any in the next 5 seconds?
One of
The answer to that.
1,000.
So one that's been making the news we didn't get to cover was the fact that this Kuiper Belt object that was recently discovered, 2007 OR10, has this tiny little moon around it. And this tells us that as we continue to explore the Kuiper Belt, we're going to find more and more complicated systems, just like we see with Pluto.
We find that about 20% of Kuiper Belt objects over a certain size have moons. And we actually see that as well in near-Earth asteroids, that about 16% of near-Earth asteroids over 200 meters have moons. So the binary things have moons in the solar system, and sometimes they have multiple moons, which is wild. So that's super cool.
That's awesome. All right, well, why don't we wrap things up here? We'll give you guys a chance to let people know where they can find out more. Let's see if I can get everybody up there. All right, cool. So, Nicole, where do people find out more?
Hi, I'm Noisy Astronomer. I'm on Twitter occasionally. Most of the time I'm doing class prep or grading, but I'm still around.
and Noisy Astronomer on Twitter. Morgan first. Where do we find out more?
Yeah, you can follow me on Twitter at Morgan Renberg. I've been tweeting some of my favorite things from the conference this week. You can always check my website out, morganrenberg.com.
Sondi.
I'm Alessandra Springman. Most people know me as Sondi. I have Sondi.com, and I'm Sondi on Twitter. I've been posting some things from the meeting, and you can follow me there, and you can find some things about me at Sondi.com.
All right. We'll give you one last chance to let people know to go to your Hist Astro.
Hist Astro.
That's
at
awesome.
Hist Astro.
Fantastic. All right, once again, I'm Fraser Cain, publisher of Universe Today. We've got lots of great stories on Universe Today for you this week, including many of the stories that you heard about today. As well, we've been publishing lots of fun videos here on this YouTube channel. We started up a new segment on Mondays where we play some video games. By the way, I need to gather each one of you and bring you in for an hour of gaming with me at some point with my son and I.
I don't play video games.
Well, you don't have to play. You just have to watch and hang out.
Okay.
But we did our first one with Dr. Paul Matt-Sutter on Monday, which was a lot of fun. We've got Jolene Creighton from Futurism is going to be joining on next Monday, and hopefully I'll be able to queue some of you up as well. So we do that. So if you want to watch any of the stuff that we do, just click subscribe wherever you're watching this. And if you want to get notified when these things actually happen, make sure you click on the little bell beside the notification, and that way your phone will freak out when we go live on here on the YouTube. So thank you, everyone, for watching. Thanks, as always, to the WSH crew for running the chat, for organizing the guests, for really being the wind beneath our wings. We really appreciate all your help. So thanks, everyone. We'll see you all next week. I'm going to stop the stream now.
All right, we got to run, Fraser.
I got to check out.